Hello, welcome to lesson 3 where we will start to factor using GCF and difference of two squares. But before we do that, we are going to simplify things that are written already in factored form. Remember, a factor is a number or quantity that when multiplied with another produces a given expression. So for number 1, our two factors are 7r and 2r minus 7. So if I want to simplify this, I'm going to multiply it. So to do that, I'm going to distribute and get my answer. 7r times 2r. I take the coefficients, the numbers in front, and I multiply them. So I get 14. R times r, we add the exponent or exponents. We're going to get r squared. Okay, so our first term here is 14r squared. Remember, when you're multiplying variables, they don't have to be like terms. You would add the exponents. So there are those little invisible ones on the r's. Okay, and then 7r times 7 is going to be minus 49r. And that is simplified. That's as much as I can simplify this expression. I can't subtract these two terms because one of the r's has a 2 as an exponent, the other one has a 1. If I had an r squared minus another r squared, then yes, I can combine those. But if they're not the same exponents, this is as far as I can go. Okay? For number 2, you're going to distribute here and here. Then you're going to distribute here and here. And once you do that, chances are there will be like terms. There are going to be values where you're going to be able to combine the coefficients and be able to write it as one term. So I want you to try that. Pause the video. Let's see what answer you get. All right, so your simplified expression should be 8y squared minus 60y. That's it. You leave your answer. This is not an equation. You are not solving this for y. There is no equal sign. You can't tell me what y equals. I could substitute any value for y here and evaluate this, but there's no equal sign. I am not solving it. Okay, looking at number 3 here, we have a binomial, 2 terms, times another binomial, 2 terms. We no longer have a monomial, 1 term times a binomial or a trinomial. It's a binomial times a binomial. And when we do that, there's the acronym that you've probably heard of, which is FOIL. Here's what each letter in this acronym stands for. F stands for first times first. So you would do P times P. O stands for the outer terms. So P times this plus 4. I stands for the inner terms. The ones are towards the inside of each other. And then the L stands for the last terms. So this times this. Now, not every teacher that you've had probably in algebra called it FOIL. Some people just call it distributing, where you have to take first term times first term, O is outer term times outer term, I is inner times inner. So every term from the first binomial gets multiplied by every term in the second binomial. If you do this correctly, you get this little, looks like one of those lemon head guys from the candy boxes, but that's what we're going to get. So I'm going to go through that one more time in a different color. If I did P times P, that's F. That's P squared, because remember we add the exponents. Outer terms, outside terms, P times 4 is going to be plus 4P. Inner is going to be minus 2P. And then the last terms, negative 2 times 4 is going to be minus 8. Notice here, you have to then look, do I have any like terms? Like terms, again, being the same variable or variables to the same power. They have to be to the same power. So P squared, there's no other P squared. That's my final answer. 4P minus 2P is going to leave me with plus 2P and then minus 8. Okay, and that's my final answer. There's nothing I can do more with this expression. It's just simplified, multiplied out. For number 4, we have a binomial squared. And when you have a binomial squared, what that means is this entire binomial is being multiplied with itself. So many times, to make that easier to see, you write it out twice. What this does not equal, many kids think that it's going to be, oh, I'm just going to square both of these. I get 64x squared and then minus 9. That is very, very wrong, but is also very, very, very common mistake in mathematics that children make. So please don't do that. When you see a binomial being squared, you take the binomial times itself, right? Go ahead and FOIL this, and let's see what you get after you simplify. Okay, after you do FOIL or distributive property, whichever way you were taught, it's the same thing, same process. It's not two different methods, it's just named, people name it a certain way. 64x squared minus 48x plus 9. Number 5 is another foiling. Please go ahead and do that, and let's check our answer. Right, so what you should have gotten is 4x squared minus 25. Remember, when I pause the video and I give you a moment to work on these, we do expect when we're going to check in notes that you're going to have work. Don't just have the answer that I put there, okay? If you don't get the correct answer, please make sure you ask in class, but we are going to be expecting to see that work, not my final solution. All right, so what happened here is when you did your outer terms and your inner terms, they were opposites. We had a plus 10x and a minus 2x. And the reason that that happens is inside here, these binomials are almost the same. The middle sign is the opposite. So if one's a plus, the other one's a minus. Those are called conjugates. Not that you need to know that name necessarily now, but anytime you have conjugates, the outer and inner terms, when you FOIL, they are going to cancel each other out. Okay? All right, so today we're going to begin our first set of factoring, and whenever you factor, we're going to learn different methods, and it's going to be whether you have 2 terms, 3 terms, 4 terms, however many terms. Your first and most important step is always look for a GCF, the greatest common factor, of however many terms you have. Whether you have a binomial, a trinomial, what have you, you always first want to look for the greatest common factor. So the greatest common factor is the highest number that can be divided into all of the terms. And if those terms have variables, you have to take that into account as well. What I'm going to do now is I'm going to do prime factorization for both of these just to see where this comes from. I'm not going to do this ever again because this should become second nature to you. But I'm going to rewrite both of these terms in prime form. 4 is going to be 2 times 2. And then the g's, if I separate g cubed, I'm going to have g times g times g. For 10, that's going to be 2 times 5, and then 2 g's. When looking for the greatest common factor, you find what they have in common. They both have a 2. They have a g here and a g there. So the GCF, the greatest common factor, you're going to go and multiply that together. So it's going to be 2g squared. If they had like a 3 in common as well, it would be 6g squared. Okay, so I always tell my students, okay, let's look at the coefficients first. 4 and 10. What is the biggest number that can be divided into both of those? 2. Then I say, okay, let's look at the variables. We have g cubed and g squared. You always take the smallest of the 2. So whichever one has the lower variable, you take that value of the variable. All right, so now think of this as distributive property in reverse. 2 times what is 4? 2. 2 times, or g squared times what is going to get us g squared? G cubed, g. Okay, if we have a plus sign here, we're going to have a plus in the middle, and now distributive property in reverse again. 2g squared times what is going to be 10g squared? 5. And that's it. The g's are already accounted for there. I would strongly suggest that you take your answer and just multiply it back out in your mind. 2g squared times 2g, okay, that's 4g cubed, so that's what I started with, plus 10g squared. Remember, when you factor, you don't want to change this expression. It's going to look differently because you're going to write it in factored form, things being multiplied together, whereas you start off with it already multiplied out, but you don't want to change its value, okay? You want it to be exactly what it was. It's just going to be the product of two things. So for example, instead of writing 12, you would write 2 times 6 or 3 times 4. That is 12 in factored form. I'm not changing 12. If I say 12 is equal to 2 times 6, that is a fact. Just like here, 4g cubed plus 10g squared is equal to 2g squared times the quantity 2g plus 5. For number 7, we have a trinomial that we are going to factor. So if you look back up at number 3, what we ended up with was a trinomial. Now I'm going to write the problem again over here. We had p minus 2 times p plus 4. And what we ended up with is p squared plus 2p minus 8. What I want you to look at is the pattern. Here we had a negative 2 and a positive 4. Notice they add up to be the middle number. When you multiply them, okay, they multiply to be that last number. So what we're doing when we're factoring a trinomial is we are looking for two numbers that are going to add up to be the middle number and multiply to be the last number. Now, as the signs change, if you have positives, negatives, it's going to become a little bit more difficult. As soon as we throw a number in here in the next lesson, that's going to make it a little bit more difficult. But for now, these aren't too bad because I know it's going to have to be a binomial times a binomial to equal a trinomial in our case. And the only way that I could get x squared is x and x. If that was a 4x squared, it could be an x and 4x, it could be a 2x and 2x, and so on. But for now, it's only x and x. So what two numbers will add up to be 7 and at the same time they have to multiply to be 10, 2, and 5? These last two numbers have to be multiples of the last number because there are other multiples of 10. I could have put 1 and 10 there, but 1 and 10 will not add up to 7. So that's why those are not numbers that I would use. I use 2 and 5. They have to be very specifically, they have to satisfy two conditions. Multiply to be the last number, add up to be the middle number. And now, if you wanted to check your answer, you absolutely can. You would FOIL it. X squared, outer is plus 5x, inner is plus 2x, and then last times last is plus 10. Combine these two, we get x squared plus 7x plus 10. And that's our final answer. I would like you to try number 8 on your own and then check your answer tomorrow. Now with number 8, just to give you a little heads up, we are looking for two numbers that multiply, remember, to be positive 12 and add up, that's a weird way to write add up to negative 7. So to multiply to be a positive number, if we're looking for two numbers to multiply to be a positive number, remember they either both have to be positive or they both have to be negative. The fact that they have to add up to a negative 7 here should clue you in that both of our numbers are going to be negative. So go ahead, try that one on your own, and we will check it tomorrow. Okay, for number 9, right off the bat, it looks a little bit different. There's a 3. There's a leading coefficient of 3. So don't forget the number one step to factoring is the greatest common factor. These three terms have a 3 in common. So it's 3, and then inside the parentheses, I'm going to divide all three terms by 3. So it'd be minus 2x minus 15. But now that I take a GCF out does not mean that I'm necessarily done. I might have two numbers, and I like to make a little T-chart. They have to multiply to be negative 15 and at the same time add up to negative 2. So this is multiply, add up. Factors of 15, 1 and 15, 3 and 5. We have to figure out a combination here that is going to, at the same time, multiply to be negative 2. So now, we are looking for two numbers that are going to multiply and give us a negative product. That means one has to be positive and one has to be negative. No combination of 1 and 15 is going to ever add up to negative 2. 3 and 5, they will add up to negative 2 only if the 5 is negative, because 3 plus negative 5 does equal negative 2. If I did it the opposite way, negative 3 plus positive 5, yes, those multiply to be negative 15. They do not, however, add up to negative 2. They would add up to positive 2. So my two numbers are going to be plus 3 and minus 5. All right, let's take a look at number 10 where we have two terms. Now, this is going to introduce us to a concept that's called a difference of two squares. So, difference of two squares. Now, you still want to always look and see if there's a GCF to start. But if there's not, you're looking for a pattern where you have some term that's being squared minus another term that's being squared. if there's a subtraction sign and the first term is a perfect square and the second term is a perfect square, what you have is a difference of two squares. So this will factor to be a plus b, a minus b. So you want to unsquare the first term and you want to unsquare the second term. So for this problem, I'm kind of running out of room here. If I unsquare y squared is a perfect square, so if I unsquare it, I get y and y. And then if I unsquare 100, what number times itself is 100? It's 10 and 10. One's a plus, one's a minus. Order doesn't matter. Okay, for number 11, we also have a difference of two squares. If this is a squared and this is b squared, you have to ask yourself, what was 49x squared? What would the square root of it be? What number squared is 49? 7. What number or what value squared would give us x squared? X. One's a plus, one's a minus, and then to unsquare 64, right, it's the square root of it, we have 8 and 8. Right, number 12, I'm going to let you try on your own. I will give you a hint that for this one you do have to do a GCF first and then use a difference of two squares pattern. All right, thank you so much for watching. Have a great day. Bye.